Another way that we can try to factor a binomial, something with two terms, is to use a method called the sum or difference of two cubes. Now, we already have the difference of two squares, and recall that that only works for the difference of two squares. It has to be a subtraction problem. But for cubes, it could be the sum or the difference. Well, off to the right, I've made a list already of the first 10 perfect cubes. I found these numbers by doing like 1 to the third power, 2 to the third power, 3 to the third power, and so on. If you see those numbers, that's going to be your cue that you should be trying this method, the sum or difference of two cubes. So here's how this process is going to work. Now, I've kind of written out the two formulas up here. I don't really use those formulas. I kind of just talk through the problem, so I would kind of just be listening to how I'm doing this problem. So x to the third plus 64 is the first thing we want to try to factor. Well, x to the third obviously is going to be a sign that we're doing perfect cubes because it's to the third power. And then check to see if 64 is in your list of perfect cubes, and it is. So the first thing that I'm going to do is sort of a little half step. I'm going to put a little parentheses under each of those terms, and I'm going to write to the third power. And what I want to do is in those parentheses put what number or what variable would get me the original problem. And so obviously for this first one, it's just going to be an x, because x to the third is x cubed. And then for the next parentheses, I need to think about what number cubed gets me 64. Well, there's a few ways you could do it. I know the answer is 4. There's a few ways you could do it. You could count in the list, and you could see that 64 is the fourth number in the list. You could also do a cube root of 64. If you don't know where that button is on your calculator, ask me in class and I'll show you. Or you could just guess and check. Try 3 times 3 times 3, try 4 times 4 times 4, and 4 will work. Okay? Once you have those figured out, here's how we're going to write our final answer. We're going to have one smaller parentheses and one big parentheses. This is the first time that we have parentheses that are not the same size. And then what I'm going to do is I'm going to take care of my signs. Now, here's what I remember for my signs. I'm going to go back up to where those problems are written down, or those formulas are written down. Notice the first sign is always the same as the original problem. So in the subtraction example, the first sign was a subtraction. In the plus example, the first sign's a plus. So first sign's always same. The next sign is always opposites. And the final sign, no matter what, is always a plus sign. So I remember SOP, same opposite plus, or SOP sign. So let's go ahead and get our signs figured out. So the first sign is always the same as the original problem. So my first sign this time will be a plus. My next sign will always be opposite, so a minus, and the final sign is always a plus no matter what. So get your signs taken care of. And finally, I'm ready to actually get my terms in the parentheses. The first parenthesis is easy. Take those things that you found up top and just plop them right in that first parenthesis, so x and 4. If you don't do that middle step that we did a few minutes ago, people get real confused on where that 4 came from. So there's your first parenthesis, plop those things in. For your big parentheses, take your first thing for the first blank and multiply it by itself. X times x is x squared, so that goes in the front. Let's jump to the back of the parentheses. Take the last thing and multiply that one by itself. So 4 times 4 gets you 16. So the front is the first thing times itself, the back is the last thing times itself, and then finally, to be fair for the middle, take one of each. So take x times 4 and multiply those together to get 4x. So once again, it was the first thing times itself, the last thing times itself, and then each one multiplied together. And it turns out that this is going to be your answer, your factored answer. Now, some people are saying, well, what about that trinomial? You said we should always try to factor more, and we should. So if I try to factor that trinomial, I would need two numbers that multiply to 16 and add up to -4. And you can run through all the factors you want to. You can pause the video and write them all down. You're not going to find any. It turns out that that trinomial, if you do difference of two squares correctly, or I'm sorry, difference or sum of two cubes correctly, that trinomial is going to be unfactorable. So that is going to be your final answer. Okay? Let's go ahead and try one more of these just so you can, again, hear me kind of talk through it and get a feel for how I do these problems. So let's try to factor this one. Now, right away, I see there's a problem because 16 and 250 are not in my list of perfect cubes. Also, z to the 5th is not even a perfect cube. It's z to the 5th power. So I have a bunch of problems. First thing, though, as always, we want to find a greatest common factor. And so I'm going to find out that 2 is the biggest number I can divide both of those by, but they also have a z squared in common. So let's pull out a 2z squared. Let's divide everything by 2z squared. And what's left is going to be 8 z to the third. Hey, 8's in that list of perfect cubes, and z cubed is good. And then if I divide 250 by 2, I get 125. And hey, that's also in my list of perfect cubes. It's like they planned it that way. They did. All right, so I now can use the difference of perfect cubes. And so what I'm going to do, remember that first sort of baby step, middle step, was underneath each of those, I'm going to put each thing as something to the third power. Well, to get 8, I need to do 2 cubed. And I'll need a z in there as well this time. So 2z to the third would get me 8z cubed. And remember, you can either guess and check or use the cube root button. 125 is the same thing as 5 to the third power. So I'm going to have those two as my pieces that I need. All right, then to actually factor with difference or sum of 2 cubes, 1 small parentheses and 1 big parentheses. Okay? Take care of your signs. Remember SOP sign, S-O-P. So the first sign is going to be the same as the original. In this case, it's a subtraction sign. Your next sign will be opposite, and your final sign will be always a plus sign. Okay? The first parentheses is easy. Just take those 2 things you found right there and plop them right in that first parentheses. So a 2z and then a 5. Okay, and remember, we've already taken care of our signs, so don't worry about that. Your first blank in your big parentheses is the first thing times itself. 2z times 2z is 4z squared. Be careful on that one. Then jump to the back. That's going to be the last thing times itself. So 5 times 5 is going to be 25 for the back. And finally, for your middle piece, be fair and take 1 of each. So 2z times 5, and remember, ignore your signs. 2z times 5 is going to be 10z. So that is almost our answer. Don't do all this work and then forget the really little piece, but important piece of including your greatest common factor in front. So there is going to be your completely factored answer. Again, remember that trinomial is going to be unfactorable. You can try it, but it won't factor.